Okay, good morning, everyone. We're going to go ahead and get started, so please find a seat, get settled in. This is the Cloud and Earth Engine intro breakout session. So in this session, we're going to be talking about Google Cloud, how Earth Engine is integrating with Google Cloud, how we have integrated with Google Cloud, and really how you can take advantage of that and what that means to you. Well, it's going to be a little bit of lecture, me kind of talking a little bit about what Google Cloud has to offer, but then we're going to do some kind of hands-on demos and walking through enabling certain things. We're not going to do anything too deep or anything too spicy, so don't be afraid. What we aren't going to cover in this session is, anything science related, Earth observation related. This is really some just nitty-gritty details about using Earth Engine inside Google Cloud. So this is a really big room, and this is a really big stage, and I am the only one up here on this stage. So to break the ice, I'm going to tell a joke that my 10-year-old told me this morning when I phoned home. What did the chemist say when he or she heard that oxygen and magnesium were dating? OMG, all right, way to go. That was Kel Markert in the back, so thank you for the applause. Okay, we're gonna go ahead and get started. So I'm going to introduce the teammates, friends that are gonna be helping us today. So when I call out your name, please raise your hand, and so that way people know who's going to be helping us. A little bit about me, I'm Brady Allred. I'm a cloud geographer here at Google. I've attended many Geo4Goods in the past. As a user of Earth Engine, I've attended Earth Engine summits back when they weren't combined with Geo4Good. Been using Earth Engine for a good amount of time to do some really fun stuff. Sean Woltman, where are you? Raise your hand. He's back there. Okay, thank you. Sean Woltman is our head of cloud geography. He's been at Google 14 years, I believe, so has some great experience. Michael DeWitt, are you in the room? Michael will come back. Michael's one of our senior DevRel engineers. He's been at Google, I believe, 8 years and has worked with Earth Engine almost the entire time. Kel Markert is manning our Q&A section online in the back there. Wonderful. And he joined up just recently, so about the same time I did, about 6 months ago. And Gina Donchitz, and I'm sure I mispronounced that. Gina, are you in the room? Okay, Gina is not in the room. Gina is also part of our cloud geography team, and many of you know Gina. He's been using Earth Engine for many, many years and has some wonderful solutions as well. So this session, because it's being live streamed, if you have any problems, please raise your hand, and Sean or Michael or Gina, who's ever in the room, they will come and help you. If you have a specific question, you can ask them while I'm talking, and they can help you with that. At the end, we'll kind of have some time for Q&A, including those of you who are viewing online. You can post your questions in the chat, and Kel will pick them up, and we can answer those at the end. We won't have any of the interactive Q&A until the end because it is online. But if you're having trouble, please raise your hand, and someone will come and help you. So just a little bit, just to get a feel for the room so I know who I'm talking to. We're here to talk about Google Cloud and Earth Engine. What kind of industry or discipline are people from? Raise your hand if you're on the academic side of things, academic or science. Okay, so a good number there. Raise your hand if you're on the government public sector side of things. Okay, we got a little bit of people there. What about the commercial side of things? Okay, a little bit less. And nonprofit, local communities, anything like that. Okay, good. So we got a good representation from just about everyone there. Okay, so this is what we're going to, this little bit of agenda for today, what we're going to talk about. I'm going to introduce what Google Cloud Platform is. Internally, a lot of times we call it GCP, Google Cloud Platform. And then I'm going to talk about Earth Engine's integration with Cloud Platform, and really talk about specifically, highlights a few of the services you can use as part of Earth Engine and GCP that will probably make your life a little bit easier and give you added value to Earth Engine to do some things that you can't do in Earth Engine, or to extend Earth Engine's value beyond its reach. I'm also going to talk a little bit about some of the management tools we have available within Google Cloud Platform. And then throughout it all, I'm going to be doing some walkthroughs. So as Michael said this morning, you do need some familiarity with Earth Engine. We're actually going to open up the code editor at some point, so be prepared to do that. We're going to create a Google Cloud project if your organization allows you to do that. If your organization does not allow you to do that, or prefers that you don't do that, just scoot on next to your neighbor and you can watch them do that. And so just look onto them and follow along that way. Okay, what is Google Cloud? So in a prior life, I was actually a professor, and so I'm actually used to asking questions and people giving me answers, but this is not going to work, so I'm going to have to adjust a little bit on the fly. So what Google Cloud is, it is the services and products that Google offers for individuals, nonprofits, businesses, users to use to extend those services into their workflow, into their frameworks, into their operations. We have a suite of services. Many things that you might be familiar with are Compute Engine, where we allow VMs to be run in the cloud. There's been a lot of talk about BigQuery and using that as a data store to quickly analyze and aggregate massive amounts of tabular data. Google Cloud Storage is another one that many people use, and one that we will talk about today. But the whole point of Google Cloud is to relieve you of the pain and suffering and blood, sweat, and tears and burdens that you will have if you were to do these things yourself. So all these services, this is probably pretty small to read on the screen there. If you were to do these things yourself, you are the blue. We here at Google, we are the orange or the yellow. So if you were to, for example, build a web application that integrated with Earth Engine, and you were to do that on your own, you would be in charge of the hardware. You would be in charge of monitoring and setting up the system, maintaining the system. You would be in charge of this whole suite of things if you were to do that on-prem, at your own location, in your own business or lab or whatever it may be. Our job at Google is to remove those burdens and let us manage those things so you don't have to. Now, why do we do that? It's so you can focus just on that web application, for example. It might not be a web application, it might be an API that you're trying to build. You can just focus on the problem you are trying to solve, the question you are trying to answer, instead of focusing on all the infrastructure and everything that comes with it. And so we have some different categories over there. That last category, managed services, that's really the sweet spot, and that's really where Earth Engine comes in. Earth Engine is a managed service. You don't have to manage anything. You just come in and start using Earth Engine. We take care of all the stuff in the orange or the yellow. All you have to take care is a little bit there in the blue, which the biggest chunk is primarily the content. And in an Earth Engine perspective, that's developing the scripts, developing the algorithms, developing the operations that allow you to focus on that question that you are trying to answer, or that solution you are trying to provide. So the dirty little secret is Earth Engine is already in Google Cloud. And even if you're using Earth Engine today, you are using Earth Engine in Google Cloud. What I'm going to talk about is if you can extend those possibilities and take control of a few things to get the most out of Earth Engine. The other thing, as I said earlier, is Google Cloud offers some really good management tools to be able to control, to maintain, to grant or revoke access to all the resources within Google Cloud. Why is that important? Because if you're working on a specific project, you might want to maintain something just for that project. You might want to maintain, Earth Engine assets that are only accessible to that project, to that team. You might want to be able to grant other services to be available for that project or to that team. And you also might want to be able to share those services or those assets, other things, with different projects within your organization. And so the management tools within Google Cloud are very specific, and you really gain a lot of control over lots of different things. Lastly, Google Cloud is a paid product. Many of the services in Google Cloud listed there on the screen, and if you click on that website, many of the services offer free tiers. And so you can get many different services, many different products available for free for a month or a set amount of time. But be aware, if you're using Google Cloud, there is a chance that you will incur costs. And to use certain things, you may have to enter a credit card and provide billing details. When you sign up for Google Cloud, many times you're able to get a first 90-day $300 credit to use Google Cloud services on your kind of first sign up. So please take advantage of that. Okay. So specifically, I'm going to talk now about how we can integrate, what we've done and how we can integrate cloud with Earth Engine and what it provides. We have a great website there. If you're following along on the presentation, you can click on that and get some details. So this is going to be broken up into two different parts. There on the left hand of the screen are a few key services that I'm going to discuss today that directly integrate with Earth Engine and that you can use today in Google Cloud. On the right hand of the screen are the management tools that I spoke about earlier, and a few of them: identity access and management, cloud monitoring. We're going to walk through those, give you a very sneak peek, or not a sneak peek, but a brief introduction to kind of get your feet wet on what those are and what you can do with them. So we're going to start with the services, and then we'll go to the management side of things. Okay, so one of the first ones we're going to talk about is serverless compute. And what do we mean about serverless compute? So when we talk about Google Cloud or any cloud ecosystem, the first thing that many people think of are virtual machines. The ability to spin up VMs and use those VMs to accomplish some purpose, to solve some problem. Serverless compute is providing those similar types of operations, but where you don't have to actually manage a machine. You don't have to manage the infrastructure of the machine. Some of our products that we offer on the serverless compute side you may be familiar with is App Engine. We've had a lot of demos, a lot of talk of using Earth Engine with App Engine in the past. Cloud Functions provides a lot of microservices and is really a great tool to kind of build and structure things together. And then Cloud Run is another one which allows you to run containers, so kind of more scaled up services. All of this stuff is serverless, meaning you don't have a system to maintain. You just develop the particular framework or the operation you want to run, and then you can interact with it that way. So what I'm going to show here in a moment is what a lot of our users use this for. A good example is to create a custom endpoint for an API. And the example I'm going to show is going to use Earth Engine, and it's going to show it interacting with Cloud Functions. And there's additional service on top of that, API Gateway, which is another Google Cloud service or product that allows you to control or manage an API with keys, access, quotas, things like that. So I'm going to switch over to the demo now. So you can click on that link on the slides, and you can follow along if you want. This is a particular application that was built by a team that I worked with some time ago that is going to demonstrate the ability of stitching things together. So I'm not going to show you what's under the hood, but I'm going to walk through what's happening here to give you a sense of the things that you can do. One thing I failed to say earlier is, when you run Earth Engine, an Earth Engine script, you always have to run that in an environment. And what we're going to be doing here is showing you of running an Earth Engine script in a Cloud Functions environment. So these Earth Engine scripts can be run in these serverless services, whether it's Cloud Functions, App Engine, or Cloud Run, and they can execute those scripts on your behalf. So in this particular case, we're looking at a map in the United States of land cover. One of the things you can do here is you can upload a shapefile. It's just this is just a polygon. I'm gonna zoom back out so you can see. This is just a polygon delineating an area. And in this particular app, you can click on this shapefile, this polygon, and you can hit Calculate Time Series. And it returns some information. So I'm going to kind of peel back the curtain and just talk a little bit about what's going on here so you can get a vision of how is this interacting with Google Cloud. So when you do that upload shapefile, it's actually not uploading any shapefile. That's a misnomer. What's actually happening on the client side is that shapefile is being converted to a GeoJSON. When you hit that, I'm going to do this again, clear this, and restart. When I hit, let me zoom back out so you can see. When I hit this Calculate Time Series button, I'm going to walk through the steps of what's actually happening. And if you have some experience, you can open up the dev tools, look at the network panel there, and you can actually see what's going on. So after that shapefile has been converted to a GeoJSON, what's happening is the client is sending that GeoJSON to an endpoint within Google Cloud managed by the API gateway. And it's sending a key alongside that GeoJSON because that endpoint is protected by a key, a client-side key. Just a key as if you were using Google Maps or something else. So once it's a post request, once that post request has been validated by that key, the API gateway then sends that to the Cloud function. And within the Cloud function, there's an Earth Engine script that grabs that GeoJSON and says, you know what? I'm going to do a reduce regions over some images using that polygon of that GeoJSON. So Earth Engine, that is then executed on Earth Engine, and that is sent back to the client as a GeoJSON in this case, and then displayed here on the screen. Particularly what we're looking at here is land cover, continuous land cover in the United States. So that's what's happening here. So this just to kind of give you a little bit of an intro, those are the types of things you can build with Google Cloud. There's no human intervention. You just set it up, and you set it up to accept the GeoJSON in this case, to accept the API key, and then the Cloud functions executes the Earth Engine script using that information. And then all that information is returned to the client and displayed on the web page here. One little thing I left out in this particular case, many times when you build apps like this is a very common use case, right? You want to draw a polygon or you have some delineation and you want to be able to get some information out of that. That's very easy to do in Earth Engine, and it's also very easy to do within Earth Engine apps. But when you want to get outside of Earth Engine apps and do something a little more specific, you can use setups like this. One thing I failed to say is, in this case, with these polygons, a lot of the times people end up want to analyze the same polygon over and over and over again, kind of throughout a year to see how things change. Another thing that's going on in this particular case is the results are being cached within Google Cloud. And so if that same polygon is analyzed next week or next month and the back-end information hasn't changed, it actually never makes it to Earth Engine to do the actual calculation. It'll just grab the cached result and then present that to the client. So a very brief introduction of what you can do in terms of serverless compute within Google Cloud. I'm going to go back to the slides now. Thank you. Another example, if you're following along on the slide deck, I won't go through this, but we have a service within Google Cloud called the Cloud Scheduler. You can think of this as a cron, a cron job. You have a particular Earth Engine operation that you want to run every day, every 10 minutes, every week, every month, whatever the time frequency actually is, you want to run that Earth Engine operation, and you want the results, let's say, to be exported somewhere. My old way of doing this was literally to set a reminder every 2 days on my calendar to say, run so-and-so scripts, and I would do it that way. The new way of doing this, or perhaps a better way of doing this, is to be able to set up the Cloud Scheduler to say, invoke this Earth Engine script using Cloud Functions every 2 days. You can then build some logic into your framework or into your architecture to say, did the script complete successfully? Did it fail? If it fails, it can send you an email or maybe even a text message and say, your script failed. It needs some human intervention. Go in and check out what's going wrong. And so there's a link there that has a demo on GitHub that can kind of walk you through that if you're interested. So that's another very common and very popular use case of using kind of serverless compute, plus in this case, Cloud Scheduler within the Google Cloud Platform. Okay. So we're going to switch a little bit here to leaving the serverless compute side. Again, this is just a brief introduction, and we're going to talk about cloud storage. How many of you have heard of cloud storage or cloud storage buckets before? Nearly everyone. Great. How many are using them actively? Oh, good. You guys are all experts. I should invite someone up on the stage to come and present this with me. I'm not going to go in detail here, but we have many operations within Earth Engine that can then export data to cloud storage or import data from cloud storage. The documentation there is, links are on the slide deck, and so feel free to click on those and read about it. You might ask the question is, why would I want to export, data to cloud storage? I can just export it to Google Drive. And by all means, you're free to do that, to export to Google Drive. Cloud storage just opens up many more possibilities where you can then integrate those exports into existing workflows that you have within Google Cloud, whether it's serverless compute or you're getting data outside of Earth Engine to run a large model or something within Google Cloud that can't be run in Earth Engine. Cloud storage gives you the opportunity to do that. So we have, you can export images to cloud storage as GeoTIFFs or as TF records. You can export map tiles to cloud storage. So if you're building a map visualization and want to overlay map tiles on top of Google Maps, Earth Engine has a fantastic tool to be able to do that easily and efficiently. Videos as well, and then in Earth Engine you can export tables or feature collections to cloud storage, and that one's neat because you can export them as CSV files, GeoJSONs, shape files, so on and so forth, many different formats. The other thing you can do with Earth Engine and cloud storage is you can read data from cloud storage and either read it on the fly and operate on it in Earth Engine, or you can ingest data from cloud storage into an Earth Engine asset. And so we have this function there, load GeoTIFF, which allows you to read on the fly a cloud-optimized GeoTIFF that is stored within cloud storage. This might be helpful because you might have a situation where you're working with these GeoTIFFs, or these cogs, and you want to use it in Earth Engine, but you also need to use it in some other framework or some other procedure or operation. And so you don't want redundancy. You don't want the image stored as an Earth Engine asset, and you don't want it stored as a cog as well. You could very well do that if you want, but there may be some reasons you might not want to do that. And so you can just load that single image into Earth Engine, operate on it as you would any other image in Earth Engine. All the same features and functions are available on that image. The other thing you can do is after you've exported those map tiles that I talked about earlier to Google, to a bucket, you can then read those map tiles as well into Earth Engine. For example, if you wanted to display a layer and have it render very quickly, it's just going to read those map tiles and put them in the right spot, lay them down in the right spot. This is actually very useful if you're building an Earth Engine app. Many people do that where they have already rendered a layer. They don't want it to be calculated or computed on the fly, and so they'll export those results as map tiles and just load them up into Earth Engine and that Earth Engine app. Then we have the blob function that you can read online. The blob allows you to grab small amounts of information from a cloud storage bucket, and it loads them into Earth Engine as a string, I believe. And so you would have to parse that information appropriately and correctly. Lastly, data ingestion. You can always, import data through the code editor using that upload function. But if you have massive amounts of data, large files, gigabytes worth of files, you don't want to use the code editor to do that. You can upload your data into Google Cloud Storage, into a bucket. And then you can ingest that image into Earth Engine using the command line tool, using the Python libraries or the JavaScript libraries as well. You can then ingest that data. So you can store your data in a central location in cloud storage and just simply ingest it into Earth Engine. You can also ingest, create what we call cog-backed assets. So these are cloud-optimized geotiffs. You can create a cog-backed image collection that will then reference those cogs in the cloud, and you can operate it just on as you would any other image collection within Earth Engine. Okay, we're going to move on to the next slide here. We're going to get to the hands-on stuff really, really soon. This last one is one that I get excited about because it really opens up a lot of doors. All this work we're doing in Earth Engine is not just to do work. It's not just because we love Earth observation data and we want to, work on it all day. It's not just because we're trying to get an A in a class. Most of this time when we're doing this work, we're trying to turn this information into insights, right? That is the goal of Earth Engine. Earth Engine is a fantastic tool. And it allows you to do lots of things. I have a list of things here up on the screen of just different functions and features within Earth Engine, algorithms, classifiers. You can do lots of different things in Earth Engine. But you can't do everything. And Earth Engine was not meant to do everything. It is not a vast statistical library to perform vast statistical operations on images. It can do many things very, very well, but it can't do everything. And so this is where the Cloud AI platform comes in. With the Cloud AI platform, you can actually build a very simple or a very complex model. Earth Engine can then interact with that model and then get you results. So I'm going to walk through an example that I did many years ago using the Cloud AI platform in Earth Engine. That one that I am very proud of what we did, me and my team, and we were able to produce some really cool and some very actionable information. So we had this question where we wanted to create a fractional land cover data set for the continental United States, the lower 48 states. And by fractional land cover, what I mean is not a categorical land cover data set. Categorical land cover data sets, say this pixel is tree, this pixel is urban, this pixel is water. We wanted to say this pixel is 10% tree, 50% grass, 30% bare ground, and I can't do the math on the fly, so I'm missing something. We wanted to get at that sub-pixel. A very, very good training data set collected by humans real human beings, boots on the ground, to be able to do this. We had 6 different classes: shrubs, trees, bare ground, annual grasses, perennial grasses, and litter. And we wanted to do that. And the thing that we really wanted to do, and why we use the Cloud AI platform, is we wanted to do multitask learning. We wanted to be able to produce those 6 predictions simultaneously. And you got to remember, this is fractional cover, so we're doing a regression type approach. It's not classification. This is kind of a more regression type of approach. We're trying to predict the cover from 0 to 100%. So that is something, and we wanted a model that could then do all that all at the same time. We didn't want to build 6 different models, which is how you would have to do it if you were using Earth Engine. So we decided to leverage the AI platform and do this. And so what we did is we were able to train a temporal convolutional network, which is just a fancy way of saying a one-dimensional convolution, on this data, the training data set we had. We were able to train that, and then we deployed that model within the AI platform. And the beauty here is we could then use Earth Engine to send prediction requests to the AI platform. and the AI platform would send the responses back to Earth Engine, and you could save those predictions, as an Earth Engine asset. So the reason I have the time series of CONUS there is we were giving it was a temporal convolutional network, and so we were giving it a time series approach. We had divided up the year into 6 different time steps, and we were looking at 2 years at a time. All of this was done within Earth Engine and Google, Google Cloud using the AI platform, so nothing had to leave the cloud whatsoever. So when we pulled that off, we were able to produce a data set that gave us the fractional cover for the entire CONUS domain for the past 38 years, from 1986 to present, and that was produced annually. And again, that was, again, nothing had to leave Earth Engine or Google Cloud. It was all contained within the cloud ecosystem, which made it very, very easy. Could you have done this, locally? Absolutely, but you would have to get all that information out of Earth Engine, all that entire Landsat archive out of Earth Engine, make the predictions locally, and then re-ingest it into Earth Engine. It's much more efficient and much faster doing it this way. Okay, we're going to switch gears a little bit and talk about the management tools, and this is where we're going to talk and kind of create some Google Cloud projects and kind of enable those projects and use Earth Engine against those projects. Okay, so a little bit of background. Cloud hierarchy. This is important, so pay attention. Everything in cloud starts at an organizational level. That organizational level can be optional. The organization can be you, is what I'm saying. But if you are part of an organization that uses Google Cloud, please, you might want to check with your organization first to make sure that you are able to create a Google Cloud project. In particular, universities and other organizations don't like their students creating Google Cloud projects without them knowing about it. With the next level down is you have folders, which can be representative of different labs, different departments, different organizations within the commercial, your commercial entity. Then the next level down is the project. Everything happens in a Google Cloud project. It is absolutely required. And then below that, there are the services and the resources, the virtual machines, the Google Cloud Storage bucket, and of course, now there is Earth Engine. I already said this, everything needs a cloud project. You track your usage and your quota in a cloud project. You can manage the permissions, and in particular, you can enable services and APIs for a specific project. So this is what a cloud project and a hierarchy may look like. You can work for example.com, and you have 3 different cloud projects for your 3 different operations or projects that you would be doing. You have Ecosystem Watch, because everyone's interested in watching ecosystems these days. And within that, you have Earth Engine enabled, App Engine, and Cloud Storage, and you can use them for different things. Okay, so we're going to create a project together. So I'm going to switch over to the live demo. And you should go to the code editor. So raise your hand if you're going to follow along here. Okay, good. So go to the code editor, open it up. I'm going to just reload this here just for a good measure. Okay, so once you're there, click on the right-hand side up here in the kind of the profile. I'm actually using my personal account, so this should look exactly similar to what you're looking at here. I already have a project selected, so it'll say that, but I'll walk you through this. If you click this, it's going to open up a menu. You can drop down to Change Cloud Project, or it might say Create Cloud Project, or something similar. Go down there. And it's going to give you this screen here. Choose a cloud project for your workspace. You can click Create a New Cloud Project. This is my individual account, so I'm not part of any organization. You can give that project a name. Project names, this is actually a project ID. Project IDs are unique. They cannot be replicated. They cannot be replicated within an organization. So you want to give it a unique name. As a default, it's going to say something EE-, and then your username or login for Earth Engine. So that should show up. I can try. There we go. Is that better? Okay. And then you can give it a name down here. That name at the bottom is something you can change later on. So I'm not going to hit create, but you should hit create. Now, if you do that, it may say something like you haven't agreed to the cloud terms of services. Is anyone getting that? Oh, wow, perfect. Were people able to create a project? Raise your hand. Okay, good, perfect. So once you do that, it'll create a Google Cloud project for you. I'm going to hit cancel here. And you should be able, that project ID should be in the upper right hand of the screen. One of the ways you can verify this, if you go over to assets, your newly created cloud project should actually show up. In this case, it's EE-AllredBW, my username. That should show up in your asset space. Anyone having trouble? Okay. You can click on this button right here, this home, the house, and it will open up what we call the Google Cloud Console. And this will give you all your project information for that particular project. This is where you can go in, enable different APIs. Michael, we have some help needed there. If you need some help, just raise your hand and someone will come find you. Okay, so then for good measure, what we're going to do is we're just going to load a data set in here. We're going to load the SRTM elevation data. And we're just going to add it. And if you run that, hopefully it'll just visualize. If you have this project selected, you are then running Earth Engine within that Google Cloud project. So we want to do this just to make sure you can actually execute an Earth Engine script and run something within a project. Okay, how many people did I lose? Okay, just a handful. If you need some help, raise your hand and someone will come help you. Okay, so we all now have we've created a Google Cloud project. As part of this process, when you hit that create button, Earth Engine automatically enabled the Earth Engine API for you on that project. That is something, if you have a project already created, you would have to go in and manually enable yourself. The documentation we showed earlier, or linked to earlier, has steps, step-by-step instructions on how to do that. But we tried to make it as easy as possible, so when you're doing this from the code editor, the API is already enabled. Okay, so first step down, we have our Google Cloud project. So I'm going to go back to the slides now. Okay, so we've created a project. We're going to talk a little bit about identity and access management. Now, as I said, cloud gives you lots of good tools. And what this does is it says who can do what on which resource. And the resource we're talking about today is Earth Engine. And so you can control who within your Google Cloud project can access that Google Cloud project and access Earth Engine in that project. And even at a finer level, you can control what they can do in Earth Engine. So these are some of the examples of what these different policies or roles apply to. You can give permissions and roles to an individual, a Google account that is within your project. Perhaps you have a workspace environment set up. You can give roles and permissions to service accounts. So when I talked about serverless compute, I skipped over all the nitty-gritty details of authentication and how it requires a service account to do that. We have good documentation on that you can look up. But you can give roles and permissions to service accounts. You can also manage these roles and permissions using Google Groups. So if you have a large organization or a large team that you're working with and you don't want to enable roles and permissions for every single one individually, you can just throw individuals into a Google group and enable those roles and permissions that way. And then we have a service called Cloud Identity, where you can work with other authentication measures like Microsoft AD or something like that, single sign-on measures that your company or organization or entity may be using elsewhere, and Cloud Identity integrates that with Google Cloud so they can use those logins that way. Okay. So we're going to talk about roles, predefined roles. In Earth Engine, we have predefined roles that will probably cover the vast majority of the use cases that you would experience within your project. So again, it's who can do what on an Earth Engine resource in this project, in this folder, or in this organization. So if you click on that link, if you're following along in the presentation, if you click on that link, it will open up our documentation about the particular roles that we have. So the first role up there is a viewer role, where it just gives you permission to view assets, essentially. To get in and view tasks and assets. You can't really execute any Earth Engine operations. This might be useful if you have, say you have an individual that their job is just to check to make sure something is running. This might be useful. Or better yet, you might have a script that its job is just to check to see if things are running correctly. And that way you can just grant the lowest amount of permissions for that particular script or that operation. The next one there is the Earth Engine writer role, which gives you permission to read everything, to write everything, and more importantly, to do computations, to do actual Earth Engine computations and execute the script. That would be the role that if you were assigning to individuals in your group or organization, that would be the most commonly used role. The third one there is the Earth Engine admin, which is exactly as it says. That gives you Earth Engine admin access and to be able to, to change the permissions and do other things related to Earth Engine. The last one there is because Earth Engine apps are, a separate thing. The last one there provides users or individuals or service accounts the ability to create Earth Engine apps. So if you want to be able to control who in your organization is creating Earth Engine apps and who cannot do that, that would be the role to use. So again, just looking at that hierarchy kind of diagram I showed earlier, this would be an example of, you can particularly control the roles and the permissions on the Earth Engine side in this diagram. So I'm going to switch over to a live demo, again, to kind of walk you through on how you would actually do this. And so in this case, in my project level assets, one thing I failed to mention is you can share permissions at a project level, or you can share permissions at an asset level. For example, if you wanted to just give permissions, certain individuals access to a certain asset. What I'm going to show you here is I'm going to show you how to give permissions at the project level. And so you should see your cloud project here in this asset section. If you click the little share button, it's going to open up to the Identity Access and Management console within Google Cloud. I'm going to zoom in here so people can see again. So right now, this is a new project I created. I'm the only one using this project, so it's a project of one. And so my personal email address is there. I am the only one being able to access Earth Engine through this project. But what I'm going to do is I'm going to grant access to my Google self. And so that way, my Google self will be able to access and use this project as well. So in this particular case, you could grant another individual on your team, another individual in your organization, in your company, your department, so on and so forth. So here, I'm just going to add my Google email address. And then I'm going to go down here. I'm going to assign a role. I'm going to type in Earth to filter the roles. Thankfully, Earth Engine is the only resource called Earth in Google Cloud, and so you can find it easily. And in this particular case, I'm going to give me, just because I'm not going to give myself the lowest security privileges, but I'm also not going to give my other self the highest security privileges. I'm just going to give my other self the Earth Engine resource writer privileges. And so I do that, and I hit save. and it will update the policy. And so my other self is now a Earth Engine writer on this project. My other self, I won't do it here, but it could log in and it could authenticate against Earth Engine using that other account, and I could run computations. I can access assets within this project. Feel free, if you're walking through, you can feel free to give, you can give my other self access to your project if you'd like, or you can find a friend or someone else on your team just to walk through as a demo. If you want to remove access, you can hit Edit Principal, and you can just simply remove that access, hit Save. It is updated instantaneously, and now my other self will no longer be able to use Earth Engine in this particular project. Okay, how many people do I still have with me? Oh, good, we got most people. Please raise your hand if you need some help, and Michael and Sean will come help you. If you have a question online, feel free to ask your question, and Kel will provide an answer online, and at the end, we'll take questions from everyone. Okay, I'm gonna switch back to the slides now for one last thing. The other, another neat, there's lots of different services you can use in Google Cloud. I'm not covering them all here. I'm just covering, I think, the most commonly used ones and the ones I think that would be helpful. Another one that is very helpful is to be able to monitor your Earth Engine consumption basically in real time. And I'm gonna walk through what that would look like. But what we're looking at here on the screen is just a simple plot that looks at, I can't remember which day this was taken, but it looks at our Earth Engine, my Earth Engine usage for the last hour. And in particular, you can see it's measuring what we call EECUs, Earth Engine Compute Units. And what that is kind of an abstraction of all the computational power that went in to execute that particular script or that operation, Earth Engine operation. And in this particular case, you can see at the latter end of that hour, towards the end there, I was using, at one point I was using up to 12 minutes of Earth Engine EECUs. Earth Engine, or EECUs, Earth Engine Compute Units. EECUs are measured in seconds, and so a lot of the times when you look at them in the cloud monitoring console, it will aggregate that up to minutes, hours, days, weeks, just to make it more readable. Go to the next slide here. Here's a different example of that, where on September 15th, I think it says there, of this year, doing an operation used 100 weeks of Earth Engine units, compute units. If you multiply that out, I think that's something like 17,000 Earth Engine hours, and I'm not sure what the seconds is. Someone can do that math. But what we're gonna do is I'm going to show you in real time kind of what this looks like. So before we switch to the demo real quick, if you're following along on the slides, I'll encourage you to click on the link, and that way you can do the same operation that we're doing here. Okay, we're gonna switch over to the demo. Okay, so if you clicked on the link, I'm going to refresh this just for good measure. If you click on the link, it's gonna open up this, and what we're doing in this particular script, just to give you an example, is we're using Sentinel-2 imagery to create an NDVI composite for the entire state of California. It's a very simple operation, nothing fancy going on here. If you look at the code underneath it, definitely nothing fancy there. We're masking out the clouds using the quality control bits. Again, nothing fancy, just a simple script to show, to kind of demonstrate the ability of cloud monitoring. A key thing to keep in mind here, remember my Earth Engine, my workflow is linked to this cloud project, EE-Allred BW. So that's absolutely critical, because if you want to monitor it in cloud monitoring, you have to have your work linked to a project. If you didn't get that script, you can just load you can load an image real quick as an example. You can load the SRTM elevation data and just visualize that, and it will work just as well. So just I'm just going to zoom in a little bit just to kind of show some Earth Engine usage. So what's happening right now is we zoomed in, so Earth Engine is recalculating that NDVI. And then once it loads, I'm going to pan around just to kind of, I'll zoom in a little more. I'll pan around just to build some Earth Engine usage up so we can see it in the cloud monitoring console. Move around a little bit. I'll let that load, and then we'll switch over. So we're just looking at NDVI in Central California. I think in the script I had said it just for the growing season, and I think particularly for for this year, 2022. So I'm going to go back to, what I'll do is I'll start here. Actually, I'll just do this. Scroll this down a little bit, go over to Assets. I'm going to click on the Home button again to go to the Google Cloud Console. This graph here is showing the Earth Engine API request, so we can see in real time that Earth Engine is being used. I'm going to go down here. If you don't see cloud monitoring, you may have to search for it. It may be down at the bottom. I have it pinned there just so it's up front. You can go to cloud monitoring. And then I'm going to click over here to Metrics Explorer. So if you need some help finding that, raise your hand, and Michael or Sean will come and help you find that. I'm going to zoom back out just a little bit so we can show this. And then I'm going to walk you through this. Admittedly, sometimes this Metrics Explorer, there are some nuances to it. So the first time you're using it, you can get tripped up a little bit. So just bear with us here. You go in here, you can select a metric, and you can see Earth Engine Cloud Project. Because we have the Earth Engine API enabled, because we're using these scripts in an Earth Engine, or we've linked these scripts and operations to a cloud project, this shows up. You can go over here, click Project, and you can see used EECUs, Earth Engine Compute Units. You can also see bytes, so you can monitor storage in your cloud project as well. But we're going to click this. And then we're going to click Apply. And so we're going to get a graph that looks something like this. Now, your first temptation might be to just jump in and look at this graph. But I'm going to say stop. There's a few things we need to do to make it a little more readable. And what we're going to do down here is you have to set the alignment period. And that's the aggregation that these metrics are going to be aggregated at the time period. We're going to keep it at 1 minute for right now. But we're going to click this option down here where it says Show Advanced Options. And we have to set our aligner. Right now it's set at rate, and that's not what we want. We want to be able to sum our Earth Engine compute minutes every minute. And so we're going to set this to sum. And so it's going to update our plot there. And what we're looking at is our real-time consumption of the operation that I just performed.
Okay,
and so if we go over here, for this particular minute, we can look at, we used 9.66 Earth Engine compute unit minutes. Again, it's measured in seconds, and so for this particular purpose, cloud monitoring just converts it so it's a little bit more human readable.
Just real quick, Brady, sorry, Michael, disembodied from the audience. Folks who are looking for the slides, they are not currently available on the site, but we'll publish them quickly after. I know some people were looking for the links there. Sorry about that.
And maybe we'll go back to at the end, I'll go back to the very beginning, and we have a tiny URL that we can share with you as well. I apologize for that. Thank you, Michael. And so here we're looking at, we used 9.66 minutes of Earth Engine compute units. Sometimes it's a little bit easier, instead of looking at a line, I found to look at it as a bar chart. And when you do that, in this particular case, it changed the interval to 5 minutes. Even though we have 1 minute selected, it changed it automatically to 5 minutes. It's still set on sum, and so we can see every 5 minutes what our Earth Engine usage actually is. You can change this, so you can go back 6 hours, go back a day. You can go back 6 weeks in cloud monitoring. And so if you want to be able to see what your Earth Engine usage was on operation 6 weeks ago, you can do that. Okay. Let's go back to the slides. Thank you. Actually, I think that's all I have. So we'll have a time for questions now. If you could go back to the very first slide so these individuals can get that tiny URL, that'd be fantastic. Hopefully, there you go. There's the tiny URL if you want to write that down. You can get these slides right now. I'm sorry I didn't share that at the very beginning. But we're happy to answer any questions. If you have a question that you'd like to ask me, please come up to the microphones. That way people online can hear it as well. Kel, if there's individuals online that have particular questions, perhaps we can get a mic back to you and you can read them off to us.
Hi, I was hoping you could talk about some of the differences between how images are stored as assets versus cloud-optimized geotiffs in a bucket. I ask because I've noticed some differences in computation speed. Maybe, for example, loading in like a bunch of images as an image collection and then running some reduction. Are they stored in the same way? And is there any way to speed up working with images that are stored in buckets? Thanks.
Thank you. So I'm going to give my first attempt, then I'll hand it over to Michael, who'll give more of the engineering answer. So they are not stored in the same way. And I think most experience is similar to yours, that Earth Engine assets will have slightly better performance than COG-backed assets. Michael, do you have anything to add there?
Yeah, it's about a 40% difference that we see in practice. 40% higher overhead if you are reading from a cloud-optimized geotiff as opposed to an Earth Engine asset. It's a little bit, it's the price you pay for flexibility is the way I frame it, because the cloud-optimized geotiffs are something that you manage. We're looking to make that better with some more sophisticated caching and things, but I would continue to expect that there's a bit higher overhead there. It looks like Sean's got a follow-on.
Yeah, just as a design decision, right? Why would you want to maybe use a cog versus ingesting the asset? Part of it goes into how often you're going to use that asset, right? So if the situation is, I'm getting an image, maybe I've subscribed to Planet, I'm getting a single image in, I'm calculating NDVI from it once, and I'm done. I don't need to store that and share it and reanalyze it later. Why spend the time to ingest it just to run that analysis, right? So that's one of the decisions that goes into it. Yes, you'll pay that 30 to 40% overhead, but you don't have to double your storage, and you don't have to store an asset in two places that you're never going to use again.
Come on up.
Hi, thank you so much for the wonderful talk. I'm Shayan Chaudhary. Yesterday I mentioned I was a student at Columbia, but I also work as a researcher at the medical center, primarily working on machine learning. So you had mentioned a really interesting point about temporal convolutional networks, right? Which is kind of using the concepts of convolutional networks and also recurrent neural networks. I'm more so on the technical side, using ML in the context of neurobiological data, but I'd be interested in hearing what sort of different applications have you used temporal, spatial, sort of CNNs in that context, other than the one that you'd shown, right?
Yeah, fantastic question. And disclaimer, I am not an ML expert by any sorts of the means. I'm a trained vegetation ecologist, and I gravitated to that tool because it gave us the best results. And so in particular, we chose it for that multitask learning. We want to be able, the model to be able to learn those different classes all at the same time simultaneously. And the convolutions were performed on that time series data. In this particular case, my intuition is it did so well because of the question we were asking. We were asking not what a pixel was, but how much of something was in that particular pixel, right? We were trying to get a quantity. We had already decided what's in that pixel based on the classes that we picked, and we wanted to get a quantity of what that was. And in that particular case, time turned out to be much more important than space. We weren't doing object detection, for example. We were just trying to determine that quantity, so the temporal information was much more important than the spatial information. And we can talk later. We can talk more about it later.
I'd love to, honestly, but thank you so much.
Hey, Brady, this is Sam. I had a quick question. It relates, well, I have a couple of quick questions. One was when you're showing the RAP platform, and you talked about how the propagation happens in terms of authentication. How does error propagation happen backward?
Error propagation.
So let's say I choose a vector that was the size of the entire United States, and you're doing reducer, and it's going to fail.
Yeah.
How do you propagate back that error, or do you do a quick check to see how big the geometry is?
You can. In this particular case, we don't, or we didn't, right? There's not very many error checks built into that operation, but you could most definitely put in some error checks. And so if it fails, the response could indicate an error and display an appropriate error message, for example.
Okay. And there is some way of mechanistically determining lag times for running a function? Like, if it scales by this much, this is going to be the lag?
If you could figure out the logic, you could do that. And so I'd have to think about that.
Okay. And the two other questions, one is related to the fact, I know that there's a limit of service accounts, how many service accounts you can register. But when you create an Earth Engine app, the app itself is a service account that's attached to a single project. How many apps can you create? Is there a limit on how many service accounts you can do based on app creation?
I'd love to take that. As we're rolling out the cloud project-based access, we are doing away with the per account service account limits. So as many service accounts as your project is able to create, which I think
As
is
1,000, yeah.
Yeah, it's up there. Those limits will soon go away, that limit of 5 service accounts per Earth Engine user, as we transition to this cloud project-based world.
And for now, the app accounts and the service accounts that you're registering for other purposes don't compete, right?
Correct.
Okay. And the last question I had, which was permissions. You showed us the permissions for readers and writers. Is there something in terms of design that could be an intermediate? Here's why. A writer also has the access to delete everything, which means that if I want, for example, if I'm an educator and I have a student, I have a classroom full of people, I want to give them possibility of importing assets into Google Earth Engine. If you give them reader access, they can't really do that. They can only list objects, but they can't really do anything with that access. But if I give them writer access, that means they can delete anyone else's collections. I'm not saying that they will, but it's possible.
Yeah, so the ones I shared are the predefined roles, and we have the custom roles that are very granular, and you can set those till your heart's content.
Is there a page?
We're out of time, so
Okay.
I got this
Thanks
thing
again.
flashing on me saying time to wrap up. So, thank you, everyone. If you have any additional questions, please catch any of us throughout the summit.